So hello, BS Pharmacy first year. Since we did not have classes since Friday last week, I guess that's two meetings already. Instead of uh, we have class through Zoom or sa big blue button, let's have this one. I hope you will um, watch this video and then you will learn more about inorganic chemistry. So this is just a continuation of our lesson during our first meeting. So let me have a recap first before I'll start with the new lesson. So we have inorganic chemistry last time. We defined what is chemistry. So do not forget that it's the study of matter. All about matter, including its composition, its structure, their properties also, and then the changes that matter undergoes. So we also defined matter. So when you say matter, it's anything that occupies space and has mass. So we also differentiated mass and weight. You just have to remember that when you say weight, there is influence of gravity. While when you say mass, it just it refers to the amount of matter or amount of um, substance present in your sample or material. Yeah, we also have units of measurement. You have to familiarize you have to be familiar with the SI unit. That's the International Standard of Unit. These are the accepted. For example, like for the length, you have here meter. Ayan. And so on, no? You have to remember also about the Kelvin, that is the SI unit, not the Celsius, because it has the absolute zero. So when you say zero, for Kelvin, zero talaga siya, compared to Celsius na we have a negative na measurement for both Celsius and Fahrenheit. Okay, please be familiar with the conversion also. So last time, I gave you a much more, what do you call that? Easier na formula for temperature conversion. So let me first, ayan, let's have a review. So I have given you this formula. You have degree Celsius is equal to degree Fahrenheit minus 32 divided by 1.8. And then, okay, instead of 5/9, we'll be using 1/8. Kasi most of the students are confused with 5/9 and 9/5. So you have degree Fahrenheit also is equal to it's degree Celsius times 1.8 plus 32. Ayan, yung kaibahan nila. Ayan. Sige. Okay, and then we also discussed the classification of our matter. So when you say matter, do not forget that atoms are the basic unit of matter. So how do we classify our matter? So let me draw a diagram here. You want to classify matter. This is classified into two. So you have here pure substances. And then on the other side, we have mixtures. So under pure substances, we have two types. We have the elements, and we also have the compounds. Ayan. But when you say mixtures, these are further divided or classified into two. We have homogeneous and heterogeneous. Sorry, that's heterogeneous mixture. Ayan. That's how we classify our matter. And then I want you to take note that elements can be classified into three. You have metals. Sa gitna, we have the metalloids, or we simply call them semi-metals. And then we also have non-metals. And for our compounds, please do not forget that we can also classify our compounds into three. So we have acids, bases, and the last one, we have the salts. Okay, so that's how we classify them. Ayan. This is a much more, what do you call it, clearer illustration of the classification of matter. Ayan, so that's matter, pure substance. Under the pure substance, elements and compounds. And then under the mixtures, we have two subclassifications, homogeneous and heterogeneous mixtures. Okay, let's define them one by one. So when you say elements, these are the simplest form of our matter. And one element is actually made up of one kind of material or atom. So when you say hydrogen element, its component is one type of atom only, which is hydrogen atom. If hindi na yan hydrogen atom, ang component ng iyong element, then it's not hydrogen anymore. Okay, so that's element. So again, elements can be classified as either metals, non-metals, and the semi-metals, or we call them metalloids. So when you say metals, they are good conductors of electricity and heat. So for example, we have gold, which is the king of all metals. So tinatawag siyang king of all metals because among the metals, gold is the best conductor of heat and electricity. Now, when you say metalloids, their properties are in between metals and non-metals. So what's the property now of our non-metal? So when you say non-metals, they are not good conductors, or they are poor conductors of electricity and heat. So carbon is an example of a non-metal. Most of our non-metals are found on the upper right corner of the periodic table of elements. Now, how about the compounds? So when you say compounds, they are substances combined together. Most likely, they are two or more elements. They are two or more elements combined together. Take note of the word chemically. So there is a chemical reaction there. And then they are combined together in definite proportion. So for example, you have water. Ayan, water, that's H2O. Hydrogen, two atoms of hydrogen and one atom of oxygen are chemically combined with each other, and then there is definite proportion. When you say definite proportion, when you say water, it contains two hydrogen and then one oxygen. If hindi na ganito yung proportion niya, hindi na yan siya water. So for example, you have H2O2. This is not water anymore, though this still contains hydrogen and oxygen, but you have there two hydrogen but two oxygen. So this is not water, this is called hydrogen peroxide. So in the market, hydrogen peroxide is best known as your agua oxigenada, which we use as antiseptic or for cleansing the wound. And let me clear all the drawings first. Now, let's move on to mixtures. So for the mixtures naman, let's differentiate them with the compound so that you will not be confused. We have two or more substances that are not chemically combined. So yung mixtures natin, class, pwede siyang one element plus a compound, that can be classified as mixture, or pwede siyang compound plus compound, mixture pa rin yun, or many compounds, kahit ilan pa yan siya, basta pinaghalo-halo na and then there is no chemical reaction involved, then that is called a mixture. So one example of a mixture is when you dissolve, like example, you have a beaker and then you have water here and then you dissolve the table salt. So table salt. The chemical name for the table salt is sodium chloride. Yan. So when you dissolve this, the crystals, ayan, there will be breaking down of the crystal lattice form of the sodium chloride, but there is no chemical reaction that takes place between the crystals and the water. So the crystals and the water are just combined physically. We call it mixture. So to check if you really watched this video, I want you to answer in the discussion. I will be making a thread under week 2 lecture na folder. Meron akong gagawing thread doon and then you have to answer. So this one is the first question. So question number 1, please give 5 examples of mixtures. So you have to answer one by one. This will be recorded as your participation for pharmaceutical inorganic chemistry. So question number 1 again, please give 5 examples of mixtures in the thread found in week 2 folder. Yeah. Okay, let me delete the writings again. Okay. So let's have a review again of the classification of mixtures. So first, according to the nature of particles, we have 2. We have homogeneous, that's one phase solution, and heterogeneous, that's more than one phase. When you say homo, that's one phase, or uniform yung appearance nila. Like yung example ko kanina, if you dissolve sodium chloride, your asin, in water, you will get one phase only and that is liquid. So that's under homogeneous mixtures. But if you have substances combined together physically and then you will get more than one phase, example, meron siyang liquid, meron din siyang solid, that will be under heterogeneous mixtures. Ayan. So, by the way, since sinabi ko na yung sodium chloride plus water, hindi na siya kasali dapat sa answer nyo sa thread natin. Okay. Now, another way of classifying our mixtures is according to the size of particles. So we have 3. First, we have the solution. So when you say solution, it's a uniform mixture. This will be under the homogeneous mixture. Again, when you say solution, you will get here a uniform mixture, which means you only have one phase here. Thus, solution is under the homogeneous mixture. Now, if you are asked what are the components of our solution, so we have here solute and solvent. So most of the time, solute is solid. I'm not saying that solid lang talaga siya, but most of the time solid, but it can also be a liquid or a gas. But what you have to take note is that when you say solute, these are substances that you are going to dissolve in a liquid, most of the time liquid, so that you will have a solution. Now for the solvent, again, most of the time solvents are liquid. How do you define this? These are the substances you use to dissolve your solute. Ayan. And then another thing that you have to take note is our universal solvent is water. Again, the universal solvent is water. So it's a universal solvent because water can dissolve a lot of solute. So meron tayong maraming masyado na solute na pwedeng ma-dissolve sa water. That is why, again, it is called the universal solvent. Next, we have another classification of our mixtures. We have suspension, or we call it coarse mixture. So, anong pinagkaiba nito sa solution? Sa solution, you will get a uniform mixture. But in a suspension, you will have two or more phases. Meaning, even if you physically combine two substances, for example, solid and liquid, the product will be two or more na, what do you call that? Two or more phases, which means yung solid mo hindi talaga na-dissolve sa liquid. So, ang labas niyan, the solid materials are just being distributed in your liquid. Just, for example, in the case of antibiotic. So, I don't know if you have experienced buying antibiotic, but I believe your parents did experience. So, yung nabibili natin na antibiotics sa, sa pharmacy, so mas lalo na yung pambata, di ba? Most of the time, it's in the form of powder. So, powder for reconstitution yung nakalagay sa label. So, powder yan siya, and meron kasing mga customer na pinapa-reconstitute nila sa pharmacy. So, when you say reconstitution, yun yung imimix mo ngayon yung powder mo sa water. So, pag mix niyan, class, yung antibiotic, yung powder, hindi talaga siya nadi-dissolve sa water. Instead, it's evenly distributed in your water, and then andoon lang siya, nakasuspend, hindi siya nadi-dissolve. So when you look at the antibiotic suspension, you will see the liquid part and the solid na phase. So that's a suspension. And another thing, when you say suspension, yung mga particles nito are actually coarse, meaning malalaki. Kaya nga tinawag siyang coarse mixtures. Kasi meron pa tayong isa, we call it colloid. So, just like the suspension, yung colloid natin ay merong two or more phases. They are physically combined, but unlike solution, yung solid natin dito hindi din nadi-dissolve. Pero yung kaibahan nila ng suspension, mas maliliit ang particles sa colloid. They're also suspended in our liquid, but again, mas maliliit sila. Therefore, sa suspension, nakikita mo yung solid phase, pero sa colloid, hindi mo siya agad-agad makikita. Except na lang kung gagamit ka ng, for example, source of light. So, for example, flashlight, ayan, ilalight mo siya ngayon, dun mo pa makikita yung mga particles ng iyong colloid. So, ayun yung kaibahan nila ng suspension. So, for example, examples ng colloids, we have mayonnaise and ketchup. So, meron kang hindi uniform yung mixture mo dyan. So, to clarify, solution is under homogeneous mixture, while suspension and colloids are under heterogeneous mixture. Yan. And then, properties of colloids. So, last meeting, we discussed what is Tyndall effect and Brownian movement. So when you say Tyndall effect, this is the ability of our colloid to scatter light. So one example of our colloid is yung milk natin. So, example, advertisement, Bear Brand. So, ayan, yung powder na yan, pag nilagay mo siya sa water, actually, hindi mo naman agad-agad makikita yung particle na hindi pala na-dissolve. So, paano mo siya makita? Example, meron kang flashlight. Okay, forgive me, I don't know how to draw a flashlight. Yan. Ayan, so, ayan, meron ka ng source of light. So ang tendency niyan, mag-scatter ang light, and by the time na meron na siyang light dyan, you will see the small particles being suspended in your colloid. Ayan yung Tyndall effect, the ability to scatter light. And then you have another property, we have the Brownian movement. So this is the zigzag movement of the particles in your colloid. Ayan. So when you say zigzag, we have another here. This is still milk. So itong mga particles na to, they are in constant motion. Nagmo-move talaga sila, but actually they don't have a pattern in terms of their movement. So random yung pag-move nila. Or let's add here random movement or zigzag movement of the particles sa colloid. So we call that again Brownian movement. Okay, so let me erase again. Okay, and then we have processes of separating mixtures. Since again, mixtures are just combined physically, then we can easily separate them. So the process of separating them are also physical processes. So we have decantation. So when you say decantation again, you will just separate the components of your mixtures by virtue of their specific gravity or density. Meaning, the one that is heavier will settle down at the bottom of your container and you can just decant. Hihiwalay mo ngayon yung liquid part mo. Kaya yung example ko last time, we have yung nagsasaing ka ng bigas, di ba, hinuhugasan natin yung rice, and then nagsisettle sa bottom yung rice, meaning that's heavier, and then you can now separate the liquid. Tatapon mo yung liquid. That's decantation. And then we have distillation. We really do distillation in the laboratory, but this involves two processes. We have evaporation and then condensation. So most of the time when we do distillation, this involves liquid plus liquid na mixture. And then what we have to do is to let the first mixture first component na mag-evaporate, magiging gas siya. And then yung gas mapupunta sa condenser na part. Merong condenser na part yung distillation setup natin. And then doon sa condenser na part, syempre mag-undergo siya ng condensation. When you say condensation, it's transforming your gas to liquid again. So makukuha mo na siya ngayon doon sa receiving flask mo, and then naiwan na doon sa original flask mo yung isa pang component. Ayan, so we have evaporation and condensation. So syempre we have evaporation also. So you experience this one even in your high school when you were asked to separate a salt solution. Lalagay natin yung solution natin sa evaporating dish, and then i-heat natin siya until the liquid or the water will evaporate, and then maiiwan yung salt doon sa evaporating dish. Then we have magnetic separation also. For example, we want to separate mixture of iron plus sand. Ayan, parati natin yung ginagawa. We played with this nung bata pa tayo. And then we have filtration. So most of the time we use filter paper. But as you go on with your laboratory experience sa pharmacy, you will encounter a lot of filtering medium aside from the filter paper. And then we have sorting. This is just mechanical separation where you just separate things that you want to separate. Like kung naglalaba ka, you want to separate yung puti at saka bicolor, we call that sorting, mechanical separation. And then most medical technologists would do centrifugation. with the use of a centrifuge machine. Most of the time, yung hinihiwalay nila dito is yung blood if they want to get the plasma. So, ang process nitong centrifugation is lalagay mo sa loob ng test tube yung sample mo, then lalagay mo siya inside the centrifuge machine, and then iikot yan siya for some time. And then, pagkatapos niyang umikot-ikot doon sa centrifuge machine, magsisettle na yung, like example, solid part ng mixture mo, magsisettle siya at the bottom. And then, you can just do decantation after. And then we have fractional crystallization, wherein just have to lower down the temperature, even lower than 0 degrees Celsius. And then the tendency for your mixture will, it will crystallize. And then yung component ng mixture mo, syempre magkaiba yung mga crystals nila. At the same time, depende kasi kung sinong unang magka-crystallize, yun yung una mong makukuha. Ayan, that's fractional crystallization. And then the last one, we have chromatography. So we will have more about chromatography when you have your QC1 and QC2. That's another subject in pharmacy. That will be in your 3rd year. Ayan, we will do chromatography. That's another thing. It's another process in separating mixtures. So, ayan, this will be the summary for the classification of matter. So we have here, can it be separated by a physical process? So pag hindi, automatic that will be under the pure substance. Now, if a pure substance can be broken down by a chemical process, we call it compound. But if it's not, it cannot be separated by a chemical process, then that's under the simple substance, or we call it element. Pero pag nahihiwalay natin siya using physical processes, like we mentioned just a while ago, yung mga decantation, etc., mixture yan siya. If the mixture is totally uniform, or you have one phase, that's under homogeneous, and then pag hindi, that will be under heterogeneous. So dito na tayo kasi we stopped last meeting here. We'll start with another lesson. I believe I told you to read about extensive and intensive properties of matter. This is actually under the physical properties of matter. So let's discuss them one by one. If you say extensive property, this is dependent on how much matter is being considered. Again, when you say extensive property, this is dependent on how much matter is being considered. So dito sa ilalim, we have some examples of the extensive properties. Example, volume. So ganito, pag sinabi mong extensive property, pag dumadami yung amount ng material mo, tumataas din ang value ng extensive property. Sa volume, kapag dumadami yung substance mo, syempre tataas din yung volume. The same thing with mass. Pag marami na yung substance, tataas din yung mass, tataas din yung size, tataas din yung weight, and even the length. That is why we call them extensive property. So anong pinagkaiba nito sa intensive property? Ang dapat niyong tandaan, para mas madali siyang matandaan, you have intensive, for independent. Ayan, for independent. Independent saan? Independent siya on how much matter is being considered. For example, you have here the boiling point. We all know that water boils at 100 degrees Celsius. Again, water boils at 100 degrees Celsius. Now, bakit siya intensive? Kasi yung isang baso mo ng tubig at isang drum mo na tubig, magbo-boil yan at 100 degrees Celsius. Therefore, wala siyang pakialam kung maliit man or marami yung substances mo. Constant pa rin yung boiling point. Even yung color, this is another example. Yung color ng substance natin hindi nagbabago kung dumadami siya. So as is pa rin. Kaya intensive, independent, wala siyang pakialam kung marami yung substance mo. The same thing with temperature, hindi yan hindi yan siya nagbabago kahit pa dumadami or lumiliit yung substance. The luster, especially for our metals, even if marami kang, for example, gold, ayan, hindi nagbabago ang luster ng gold natin. And even the hardness. So, ayan. So, we have more intensive properties like melting point. Hindi din yan nagbabago. Freezing point. Kahit pa madami yung substance mo, yung freezing point, pareho lang. Like we have water. Water freezes at 0 degrees Celsius. So yung isang baso mong tubig, mag-freeze yan siya at 0 degrees Celsius. And yung isang drum mo na tubig, mag-freeze pa rin at 0 degrees Celsius. So ito silang lahat, walang pakialam kung madami man or maliit yung substance. Ayan. So, ayan yung pinagkaiba nila with the intensive and extensive properties. Okay. So, ito yung properties ng matter natin. Let's summarize. So, can the property be determined without changing the identity of the substance? Pag hindi mo madedetermine ang property nang hindi i-change ang identity or property ng substance natin, it's called chemical properties. So for example, we have here, example of a chemical property is reactivity. You will not know if a substance is reactive or not if hindi mo talaga siya ipapa-react with other substance. And then pag nag-react yan siya with other substance, magbabago yan ang properties and identity niyan. Kaya under siya sa chemical properties. The same thing with flammability. Hindi mo malalaman kung flammable ba ang substance mo if hindi mo siya susunugin. And once sinunog mo siya, it will form a new identity and meron siyang bagong property. Yun yung ibig sabihin ng chemical properties. Madedetermine lang natin yan kapag binago natin ang identity ng substance natin. So other examples also include toxicity, ability to oxidize, and heat of combustion. On the other hand, kapag madedetermine mo yung property without changing the identity as is pa rin yung substance mo, it's under physical properties. Pero yung physical properties, may dalawang klase. So, ito yung question na kailangan nating sagutin. Does the property depend on the amount of the substance? So, pag hindi, meaning independent, wala siyang pakialam kung maliit man or marami yung substance mo. That's under intensive property. So, these are other examples of our intensive properties. Na-mention na kanina itong, ano na-mention natin? Color, luster, boiling point, melting point, hardness. So, dagdag natin, we have density. So, sa density class, yung water natin, ang density is 1 gram per ml. And hindi yan nagbabago kahit pa dumadami yung water mo. So, example again, isang basong tubig, the density is 1 gram per ml, and ang isang drum ng tubig, the density is still 1 gram per ml. Hindi siya again nagbabago. Kung nagbabago siya, kung dumadami yung amount, that will be under extensive properties. So we have the following examples: mass, volume, and weight. So aside from that, we also have the length. Ayan. The size also. Now, let's move on to the changes that matter undergoes. I hope hindi kayo ma-confuse kasi marami akong student na until now nako-confuse sa physical change and chemical change. So, let's start with the physical change. When you say physical change, class, there is a change in phase. Ano yung mga phases ng matter natin? We have solid, liquid, and gas. Kapag ito lang yung nag-change, class, it's under physical change. So for example, we have here solid, magiging liquid, or ang liquid, magiging gas. Kapag ganyan lang, physical property lang siya. So let's have there the names of the processes na. So we have here from solid to liquid. Kapag ka ang solid ay naging liquid, again, kapag ka ang solid ay naging liquid, anong tawag doon? We have melting. Other name for melting is fusion. Yan. Ngayon, if the liquid becomes gas, we call it evaporation. Yan. Nabaliktarin natin. If si gas magiging liquid, ang tawag doon, condensation. And then, si liquid, pag naging solid, ang tawag natin dito ay freezing. Tapos, meron tayong solid na diretsong nagiging gas, hindi na siya dumadaan sa liquid na phase. We call it sublimation. And then, the last one, kabaliktaran nito, ayan. Pag si gas naman ngayon ay maging solid, hindi din siya dadaan sa liquid na phase, ang tawag natin dyan ay deposition. So, ito silang lahat, class, from melting until deposition, silang lahat ay physical changes only. So, for example, pag ang ice ay nag-melt, that's under melting, physical change yan. Kapag kasi water, pag pinasok mo sa freezer, nagiging ice, we call it freezing, that's still physical change. Now, kapag yung water, binoil mo, and then nag-evaporate siya, naging gas, that's evaporation, that is still physical change. Yung sa sublimation naman, for example, I believe you are familiar with mothballs or yung naphthalene balls natin. I hope you are familiar with that. Ginagamit yan ng parents natin para sa cockroaches. So most of the time, they will be placing it sa cabinet. Diba? Ball, solid yan siya. So after some time, nawawala yung ball. Actually, lumiliit siya ng lumiliit hanggang nawawala talaga siya totally. But alam mo talaga na merong mothballs na nilagay sa cabinet kasi naaamoy mo siya. So that is gas. That's solid to gas. We call it sublimation. Physical change pa rin yun siya. Another thing, pag yung yung butter nag-melt, melting butter pa rin yun, no? Nag-melt lang siya, that's physical change. So again, kapag merong phase change, under yan siya sa physical change. Aside from that, changes in size, and then in shape, and form, physical change din yan. Like yung paper, kinat mo into smaller size, physical change. Kung kinat mo siya into different shape, like ginawa mo siyang circle from rectangle, that's physical change. And then, syempre, yung form, if nagbago siya, I mean, that's physical change also. So, sa physical change class, you have to take note here that there is no new substance na na-form. So, wala kang bagong substance na na-form when you say physical change. If you have any questions, I will post another thread na pwede kayong mag-post ng, mag-ask kayo ng questions doon and i-answer ko siya if meron kayong clarifications about sa ating lesson. Now, let's move on naman sa chemical change. Sa chemical change naman, class, yung nag-change is yung total property or properties ng ating substance. So, both intrinsic and extrinsic. So, again, by the way, yung intrinsic, ito yung intensive properties natin. Remember, intensive properties, ito yung mga walang pakialam kung gaano karami yung substance mo. Yung may pakialam, under yun siya sa extensive. So, itong intrinsic and extrinsic, other names lang nila. So, again, pag nag-change both ang intensive and extensive properties ng iyong substance, that will be under chemical change. So, again, you have to take note that in chemical change, there is a new substance that will be formed. Again, there is a new substance that will be formed after the reaction. So, ano ang example ng chemical change natin? Example ng ating chemical change, for example, yung example, yung napapanis ang ating pagkain, na-spoil, napanis. That is a chemical change. There is a change both in the intrinsic and extrinsic property. And meron kang bagong substance na na-form. Though pagkain pa rin yun siya, no? Pero, take note, hindi mo na siya maibabalik sa original form niya. So, you cannot change it back. Sorry. You cannot change it back to its original form. Yan. Or another example, kapag kayong banana, example, nag-ripe siya, no? Nahinog, though banana pa rin yun, pero nag-change na siya, and then yung change na nangyari ay hindi mo na maibabalik pa sa original form niya. Hindi mo na siya maibabalik sa green one kasi nahinog na siya. That's chemical change. Now, thread number 2, you have to answer sa thread number 2. Thread number 2. So, letter A. We have hair rebonding. Sasagutan nyo doon sa thread natin kung ano ba ang hair rebonding? Physical change or chemical change? And then, i-explain nyo bakit. For example, para sa inyo, hair rebonding is a physical change. And then, after that, i-explain nyo bakit physical change. Yan. And then, letter B, we have boiling an egg. Yung boiled egg. Yan, boiling an egg. Yan. Yang dalawang yan. I want you to answer this sa thread number 2 natin sa discussion under week 2 folder. Wait ha. So let's continue with the evidences of chemical change. So, ito yung mga proofs natin na merong nangyayaring chemical change between our substances. So the first one, we have evolution of gas. So in the pharmacy, wait ha, I would like to start my pen so that I can write the screen. Ayan. I don't know if you are familiar with Berocca. Yeah. Ayan. This is O and then this is double C. You have Berocca. This is actually a vitamins available in our market. Nabibili natin siya no in large tablets. And then unlike other tablets, hindi mo siya iinumin kasunod yung water. But instead, the tablet will be dissolved in water first, and then once magkaroon ng contact ang water at saka yung tablet ng Berocca, magkakaroon ng formation of bubbles. So, ito yon isa yun siyang indication na merong chemical reaction between the tablet, I mean the ingredients na andoon sa tablet mo, and then ng water. Yan. And then, aside from that, formation of precipitate. So, ano ba yung precipitate? Precipitates class are solid particles which remain undissolved in a solution. Ayan. Meron tayong mga substances like liquid plus liquid. Pag pinaghalo mo silang dalawa, magkakaroon ngayon ng formation ng solid particles. And then kahit anong stir mo dyan, hindi yan siya madedissolve. We call it we call it precipitate. Again, that's an indication na merong chemical change na nag-take place. And then emission of light also, that's an evidence of a chemical change. Generation of electricity. And then production of mechanical energy, absorption or liberation of heat. Meron tayong mga substances na pag pinaghalo natin, nagiging mainit siya. I mean, if you measure the temperature, or even hawakan mo lang, you will really feel na nag-iba yung temp, na miinit siya. That's an evidence of a chemical change. So, yun sila. 1, 2, 3, 4, 5, 6. But again, you have to take note that in chemical change, there is a new substance or substances na na-form after the reaction, and hindi mo na sila maibabalik into its original form. Ayan. And then processes involved in chemical change. Ito sila yung mga processes na chemical change. Under pa rin sila sa chemical change. So we have here oxidation. So under oxidation, what you have to take note is that merong union or combination ng oxygen with another substance. So, ang dapat yung tandaan, oxidation, meron kang oxygen. Kung hindi oxygen, yung nadadagdag sa substance mo, pwede ding loss of hydrogen. So, sa oxidation class, pwedeng merong madagdag na oxygen or merong mawawala na hydrogen. At the same time, as we go deeper with our oxidation discussion, malalaman nyo na there will be increase in the oxidation state. But before that, let's have an example. You have here 2 molecules of magnesium, 2 atoms of magnesium, plus we have oxygen. This will give you 2 molecules of magnesium oxide. So, meron kang substance here, which is magnesium, and then magko-combine siya with oxygen, forming magnesium oxide. So, merong nadagdag na oxygen sa product. Ang tawag dito, oxidation. Ayan. Wait ha. This is an example of a chemical reaction Ang part na ito ay tinatawag nating mga reactants. And itong part na ito, we have the product or the products pag marami. Ayan, again, when you say oxidation, there is gain of oxygen. Sorry. Okay. And then, we also have reduction. Yung reduction naman, kabaliktaran lang ng ating oxidation. So, in here, oxygen is removed. And aside from that, hydrogen is added. So, total opposite of the oxidation talaga siya. And then, there will be decrease in the oxidation state. Yung oxidation state, ito yung charges natin. But we will have a separate discussion for that. Ayan. So, sa reduction naman, let me write on the screen. Babalik ta rin natin. So, for example, you want to get rid of this oxygen. Ayan. Sa chemical reaction, you will have this one. So, kabaliktaran talaga siya ng oxidation. So, this one is the original formula. And then, maghihiwalay sila. You will remove oxygen and will get two atoms of magnesium and you have a molecule of oxygen. And then we have neutralization. So during our board exam, that was January 2013, this is the first question of the first area, neutralization. Yung question sa board exam namin, what are the products of the reaction of acids and bases? Yan. Yung sagot doon sa number 1 na question ng board exam namin ay salt and water. So before the board exam, I really thought na wala akong alam. I mean, walang laman yung utak ko. Parang lutang. Pumasok ako sa exam room. Feeling ko lutang. But actually, before ako pumasok, sinabihan ako ng teacher namin na Reza, pagbasa mo ng question number 1, doon mo malalaman na meron ka palang alam. So, true enough, when I read the question number 1, alam ko pala yung sagot. So, again, ito yon, neutralization. When an acid reacts with a base, you call it neutralization. And then the products of the reaction are salt and water. So let's have an example. We have here the reaction of hydrochloric acid and sodium hydroxide. Pag nag-react yan, syempre this is an acid and this is a base. Again, hydrochloric acid nag-react with sodium hydroxide. Yung makukuha mo, you have here sodium chloride. And then this is well known as your salt. And then you have here water. So all in all, we call this neutralization. Ayan, this is a process involving chemical change. The next one is hydrolysis. Now, kung si reduction ay total opposite of our oxidation, si hydrolysis naman is an opposite of neutralization. Because in here, the ones na mag-react ay yung water at saka salt. Baliktad, no? So, water and salt na yung magre-react and then you will get as products yung acid and base natin. So, magiging ganito yung reaction niya. Pag si water daw, magre-react with your salt, like sodium chloride, you will get an acid and a base, sodium hydroxide. Hydrolysis ang tawag natin dyan. Yan. Total opposite of our neutralization reaction. And then, we have the process called saponification. So, during your second year, I think that's second year, first semester. I hope wala ng pandemic by that time. You will actually conduct in the laboratory saponification. So what is saponification? It's the process of making soap. So kayo talaga ang gagawa ng sarili ninyong sabon. Again, we call it saponification. Paano ba gagawin yung soap natin? Meron ka lang alkali. When you say alkali, it can be base. Mga basic substances natin like yung kanina sodium hydroxide. Ayan. Meron kang base and meron kang fats or oil. Depende kung anong gagamitin mo. Pwedeng fats, pwede din namang oil. Pag pinag-react mo yung dalawa na yan, you will get soap at the same time glycerol. So pag pharmacist ka, alam mo talaga paano gumawa ng sarili mong sabon. Kaya merong mga pharmacists nag-venture into soap making and then yun yung parang pangkabuhayan showcase nila. Ayan. And then the last one, we have fermentation. So aside from making soap, you can also conduct this one in the laboratory. When you say fermentation, yung product mo naman ngayon is alcohol. Ayan. So gagawa din kayo nito sa laboratory. But it's not sa organic chemistry. It will be in pharmacognosy. Ang pag third year nyo naman ito gagawin, you will be making wine out of fruits. So, ang process ng paggawa ng wine or other alcoholic beverages ay fermentation. This is the action of microorganism. Pwedeng bacteria, pwede din namang yeast. Ayan, most of the time we use the yeast. Ayan. Magre-react yan ngayon sa organic substances natin. When you say organic, remember, these are substances na merong carbon sa kanilang structure. Ayan. Again, pag yung bacteria or other microorganism mo magre-react with an organic substance, you will get a product which is alcohol. So example niyan, I have tried making wine using what do you call that? Peach, yung at the same time apple and jackfruit. Ayan. So yung jackfruit, for example, pinag-react namin with yeast and then after some time, magpo-produce na yan siya ng alcohol. And then ayun, nakagawa kami ng wine out of jackfruit, apple, and then peach. So I hope sa inyong when you reach third year, magkakaroon din kayo ng experience of doing fermentation. So those are the processes involved in chemical change. Now let's move on with the nuclear change. So ano ba itong nuclear change na tinatawag? So pag sinabing nuclear change, ito talaga yung merong change sa structure, sa composition, and even properties ng nucleus ng iyong atom. Remember, yung atom mo merong nucleus sa gitna, and then merong mga orbitals na nakapalibot. So kapag ka itong nucleus na ito nag-change, ang tawag natin nuclear change. So ano bang meron sa gitna ng atom? Ano bang makikita natin sa nucleus? The nucleus contains class protons and neutrons. Sorry, this is neutrons. So pag nag-change ang proton class, it means bubuo ka ngayon ng bagong element. Therefore, pag sinabi mong nuclear change from one element, magkakaroon ka ng another element. So for example, ng nuclear change, pag pinag-react mo ang dalawang atoms ng helium, ayan, pareha silang helium ha, pero yung product mo ay this one, beryllium. So yung atom, ang nucleus ng atoms ng helium, nag-change. And then, nagkaroon ka ngayon ng beryllium. We call it nuclear change. Meron tayong dalawang klase ng nuclear change. We have nuclear fission and nuclear fusion. So pag sinabi mong fission, separation, meaning there will be splitting of a heavy atom. Meron kang malaking atom and then nag-undergo siya ng nuclear change, nag-split yon, nag-split ang malaki mong atom and then nag-form ka ngayon ng bagong atom. We call it nuclear fission. Ang kabaliktaran naman yan, we call it nuclear fusion, wherein meron kang dalawang maliliit na atoms and then nag-fuse sila, nag-combine sila together. Yan, and then meron ngayong mabubuo na bigger molecule or bigger atom. Ang tawag dyan, nuclear fusion. So silang dalawa yung types ng nuclear change natin. Yan. And then, let's discuss atomic structure. So again, when you say atoms, they are the basic unit of our matter. They are indivisible, but please do not forget that when you say atom, they contain 3 subatomic particles. Pag sinabi mong subatomic particles, ito yung protons, electrons, and neutrons. So, ang positively charged sa kanila, tandaan nyo, ay yung proton. And then, ang negatively charged, electron. Yung walang charge, neutral, that is our neutron. Ayan. So, this is our atomic structure. Ito yung tatlong subatomic particles. Please do not forget that at the center of the atom, you can see there the nucleus, and the nucleus contains both the protons and the neutrons. Wait lang ha. Ayan. Susulat natin. Sa nucleus ng ating atom, we will find there protons and the neutrons. Yan. Pag pinaghalo mo ito silang dalawa, ang tawag sa kanila, nucleons. Ayan. And then outside the nucleus, you will see in the orbitals your electrons. Yung mga negatively charged natin na subatomic particles. Now, for the atomic theory, everything started with Democritus. He coined the term atomos. So according to him, matter daw is made up of small, indivisible particles. Again, according to Democritus, yung mga matter natin, lahat ng matter, so they are composed, they are made up of small, indivisible particles which he called atomos. Now, that's according to Democritus. Now, we have another scientist. He was John Dalton. So, according to him, hindi na siya atomos. Instead, atoms na. But matter, again, is still made up of atoms. And then, pag meron kang element, so one element contains one kind of atom. So pag sinabi mong hydrogen, meron siyang hydrogen atom. Hindi pwede na si hydrogen na element magkakaroon ng helium na atom. Hindi yun pwede. So again, pag element, isang klaseng atom lang talaga yan siya. But please take note that the atoms can react with other atoms. They can even combine to form compounds. So one atom plus another atom will give you now a compound. Pero hindi yan siya nag-change in an ordinary chemical reaction. I mean, walang nuclear change na nangyayari dyan. Magno-nuclear change lang yan siya kapag ka nag-change totally yung atoms na nag-react. Kagaya nung example ko kanina na pag nag-react si helium and another atom of helium, magkakaroon siya ng beryllium. That's an example of a nuclear change. Pero pag ordinary chemical reaction lang, hindi nag-change ang mga elements natin. So for example, pag si sodium nag-react with chlorine, ayan, meron kang sodium atom and then the chlorine atom, Mag-combine yan sila forming sodium chloride. Now, this one now is a compound. And take note, walang pagbabago. Andito pa rin si sodium and andito pa rin si chloride. This is just a simple or ordinary chemical reaction. So that's according to John Dalton. And atoms can combine into simple numerical ratios. So again, you have Na plus Cl, you will have NaCl. So for example, meron kang isang sodium and meron kang isang Cl. Or for example, water. Si water, hindi siya matatawag na water pag hindi dalawa ang hydrogen at hindi isa lang ang oxygen. Ayan. So it was John Dalton who actually created the billiard ball model for our atoms. According to him, he described atom actually as a hard, indestructible sphere. So matigas na hindi natin nasisira at hindi natin na-divide na sphere. That's billiard ball model for John Dalton. But actually, this theory or this model was disproved when other scientists discovered the subatomic particles. Yeah. So this is still under the work of John Dalton. We have law of definite proportion. Pag sinabing law of definite proportion, according to this, when forming compounds, their composition or proportion is always definite. Ito yung ulit-ulit kong sinasabi na like sa water, pag water class, dalawang hydrogen, isang oxygen, talaga yan siya. Definite ang proportion ng kada element na nasa compound mo. Pag naiba ang proportion nila, ibang compound na yon. Like this one. Pag ginawa mong dalawa ang atom ng oxygen, hindi na ito water. Instead, this is now hydrogen peroxide. So again, pag sinabi mong compound, definite ang proportion ng each element involved sa compound mo. That's law of definite proportion. And then, you have J.J. Thomson. So this one ay yung third natin na scientist. So sa kanya naman, he created the raisin bread or plum pudding model. So, according to him, pag sinabi mo daw atom, para daw siyang bread na merong mga raisins on top. That's how he described atoms. Yan. Magkaiba sila ng mga description ng ating atoms. And now we have Rutherford. Rutherford gold film experiment. So his name is Ernest. Ayan, Ernest Rutherford. Ito yung name niya. So nag-experiment itong si Ernest Rutherford gamit ang gold film. So ganito yung experiment niya, class. Meron siyang gold film here and then let me delete it. Don't like it. Okay. So meron siyang gold film here. Anong ginawa niya sa gold film? Meron siyang light source. Ayan. And then, pinapass through niya yung light. So, sa experiment niya, ang result, 99% daw of the light passed through the gold film. And only 1% of the light yung bumalik, na deflect. So, ito yung mga proposal niya based sa gold film experiment niya. Since 99% of the light passed through, according to him, atom daw is mostly an empty space. Empty space, wala kang makikita, kaya nga nag-pass through yung light. And then, Since merong 1% na na-deflect na light, so ito yung proposal niya. Most of its mass and positively charged particles are concentrated in the nucleus. So it was Rutherford na nagsabi na itong protons, di ba ang positively charged natin yung mga protons. So according to him again, itong mga protons ay makikita natin sa center. He called it the nucleus. Okay. So unti-unting nabubuo ang atomic structure based sa experiment ng mga scientist na ito. And then we have Neil Bohr. So his model naman was called planetary model. So sa planetary model naman, according to Neil Bohr, meron kang sa gitna, parang sun, ayan, and then merong mga nakapalibot. So merong sun daw sa gitna, and then sa nakapalibot, merong mga planets. So ganyan daw ang structure ng ating atom. Again, he called it planetary model. And then Erwin Schrödinger, ang sa kanya naman, he discovered the orbitals. So he called it the electron cloud. So according to him, makikita daw natin ang mga electrons sa mga orbitals na nakapalibot sa nucleus. So actually, parang the same siya with the planetary model when Neil Bohr described it as merong nucleus sa gitna, parang sun, and then sa mga nakapalibot, merong mga planets. So yung mga planets na yun na nakapalibot, nasa orbitals nila, yun yung mga electrons according to Erwin Schrödinger. Yan. So again, ito yung summary ng ating theory sa atom. Everything started with Democritus. He called atoms as atomos. And then John Dalton created the billiard ball model. And then we have J.J. Thomson, who created the raisin bread model. And then it was Rutherford who discovered protons using his gold film experiment. And then may idagdag lang tayong name. So we have John Chadwick. It was he who discovered the last subatomic particle called neutron. So do not forget, when you say neutron, it's neutral. Wala siyang charge. Okay, so we are done with our discussion sa atomic structure. Now, let's move on sa ating ions. Class, yung atoms natin ay walang charge. Bakit siya walang charge? Sa atom class, pag neutral siya, pantay lang kasi yung number ng protons at saka number ng electrons. So, pag pinagsama mo yon, nakaka-cancel out yung charges nila, kaya zero. But, if yung atom class nagkaroon ng charge, ang tawag na natin sa kanya ay ion. So again, when you say ion, it's a charged atom. And then, meron tayong dalawang klaseng ion. The cation and the anion. So ito yung magiging hint ninyo. Itong T sa gitna ng cation will give you a hint na ito yung positively charged atom natin. Ayan, positively charged. And then, automatically, yung kasama niyang anion will be the negatively charged ion. Okay. Ayan. So this one, please remember this. We have here the X as the element. Please do not forget na yung sinusulat na number sa taas, ang symbol niyan ay A, ay tinatawag nating mass number. Do not forget, class, na yung mass number na yan ay pwede din nating tawagin na atomic mass or atomic Wait, parehas lang yan silang lahat. Again, the symbol is A. And take note of this. Ano ang nire-represent ng mass number? It represents the number of protons at the same time the number of neutrons. And then yung nilalagay na number sa baba, ayan, Z ang ating symbol. That's the atomic number. And ang nire-represent ng atomic number ay number of protons. Okay, so we have an example like this one, hydrogen. Si hydrogen class, yung atomic number niya ay 1. Ang atomic mass niya ay 1 din. So pag tinanong kayo, how many protons ang nasa hydrogen natin? The answer is isa. Kasi again, meron siyang isang atomic number which represents the number of protons. Now, pag tinanong din kayo, how many neutrons are there in hydrogen? So, ganito yung gagawin nyo. To make our life easier, you just have to subtract the mass number, you have to subtract the atomic number from the mass number. So, 1 minus 1, you will get 0. Therefore, si hydrogen class ay walang neutron. Kasi 'di ba, number of protons si atomic number, and then ito mass number, number of protons plus number of neutrons. So pag tinanggal mo ang number of protons, ang maiiwan number of neutrons. Kaya 0 yan dyan. Now, ang ikatatlo, if you are asked how many electrons does hydrogen contain? Ganito ang tandaan nyo. In a neutral atom, when you say neutral atom, pag walang charge ang atom ninyo, the number of protons is equal to the number of electrons. Ayan, the number of protons is equal to the number of electrons. So since dito wala kayong nakikita na charge, this is an example of a neutral atom, which means magkapareho lang ang number of protons and ang number ng electrons. Kaya 1 din ang isusulat nyo for the electrons. So again, let's have a recap. When you say atomic number, our symbol for this is Z. It represents the number of protons. But again, in a neutral atom, the number of protons is equal to the number of electrons. Yung mass number naman, our symbol for that is letter A. It represents the number of both protons and neutrons. Ayan. To give you more example, yung hindi naman 1, no, kasi si hydrogen 1, walang challenge yun. So let's have sodium. The atomic number of sodium is 11 and the mass number is 23. So you can look at the periodic table para mayroon kayong reference. By the way, sa subject ko, nire-require ko kayong lahat to memorize the names of the elements with their symbols. Plus, you have to memorize the periodic table, the arrangement of the elements in the periodic table. Later, we'll discuss that. So, let's go back to our sodium. So, you have protons, neutrons, and electrons. Ayan. So, again, pag tinanong kayo, kung ilan ang protons sa sodium, ang titingnan nyo lang ay yung atomic number niya, which is 11. Now, for the neutron, diba, sabi ko kanina, ima-minus mo lang atomic mass or mass number minus the atomic number will give you the number of neutrons. So 23 minus 11 is 12. And then, since wala kayong nakikitang charge dito, automatically, the same lang ang number of protons and electrons. Kaya, 11 pa rin. So this is again an example of a neutral atom. Okay, so let me give you an example ng hindi neutral na atom. Let's have sodium ion. So you still have 11, 23, but this time may makikita ka ng charge. So paano na? Ito. We have protons, neutrons, and electrons. So sa number of protons class, please take note na ang protons, ang number niyan hindi nagbabago. So 11 pa rin yan. Ang neutrons, the same thing. Hindi din siya nagbabago. So 23 minus 11 is 12 pa rin. Therefore, ang nagbabago lang kapag meron ka ng charge ay yung electron. So ganito. Pag positive ang charge, again, pag positive ang charge, ang meaning yan, mas marami si protons. Kung ano ang number dyan, yun yung amount kung amount yan ng protons na mas marami siya, no? Like for this 11. No, kay positive 1 yan siya, meaning mas marami ang protons ng isa. Therefore, si electron ngayon ay 10 lang. Again, pag ang charge ay positive, ang tandaan nyo, mas marami si proton. Pero again, hindi mo pwedeng pakialaman ang number ng protons. Ang pwede mo lang pakialaman ay yung number ng electrons. Kaya ang ginawa natin, nag-minus na lang tayo ng isa. So we have 10. So mas marami na ngayon si protons ng isa. Kaya positive 1. So let's have another example. We have chlorine. The atomic number of chlorine is 17 and the mass number is 35. We have protons again, neutrons, and electrons. So sa protons class, since you have atomic number of 17 here, so automatic the protons will be 17. And then sa neutrons, i-minus natin yan. 35 minus 17, you will get 18. So that's the neutrons. And then automatic, since wala itong charge, parehas lang si protons and electrons. Pero, kapag ganito, ayan, nakita nyo, negative 1. Meron na siyang charge. So again, hindi nagbabago si protons and si neutrons. Si electrons lang. Pero since this is negative, what you have to know is, pag negative ang charge, mas marami ngayon si electron. So, since this is negative 1, mas marami ng isa si electron. Meaning, ang electron dito ay 18. That's how you answer. Last example, calcium. 40. Ang mass number ng calcium ay 40. And then, ang atomic number niya ay 20. And then, meron kang positive 2. So, ang proton mo, since the atomic number is 20, so automatic, this is 20. And then, the neutrons, again, ano natin kukunin ang neutrons? Ma-minus natin, mass number minus the atomic number. So, 40 minus 20, that is still 20. And then the last one, electrons. Ngayon, meron kang charge, positive 2. Hindi na dapat magkapareho ang number ni protons at saka ni electrons. So this time again, kapag ka-positive, meaning mas mataas ang proton. This time ng dalawa. So this is, since this is 20 and then hindi mo to siya pwedeng baguhin, automatic ang gagawin natin, magma-minus na lang. Gagawin nating 18 ang electrons. So ngayon, mas madami na ang protons ng dalawa. That's how you predict the numbers of protons, neutrons, and electrons. So now, we have thread number 3. You have to discuss this sa thread number 3. I mean, you have to answer this as part of your participation. You have to give me the numbers of protons, neutrons, and electrons of the following elements. So number 1, I will not give you the atomic number and the atomic mass. You have to look at you have to look for them sa periodic table niyo. So I will give you lead. That's lead, it's not lead. Lead positive 2. I'll just give you if merong charge. So positive 2. Please take note, class, na yung mass number ang nakalagay sa periodic table merong decimal. Please round it off to the nearest whole number. Please round it off to the nearest whole number. So number 2, I'll give you aluminum. Take note, wala yung charge. And then number 3, I'll give you oxygen, negative 2. Yan. Please answer it sa thread number 3. So, ang hindi maka-answer, meaning walang grade sa participation, and ang meaning nun, hindi siya nag-watch ng video na ito. Okay. So, meron tayong mga words na kailangan nating i-define. So, sa atomic structures natin. If you encounter the word isotopes, class, it means magkapareho sila na element. Kaya lang, hindi sila magkapareho ng mass number. So, example niyan, ng ating isotopes is hydrogen. Meron kasi tayong hydrogen na ganito. We call it protium. Meron din tayong hydrogen na ganito. We call it deuterium. And the last one, you have hydrogen na 1 and then 3. So, we call this tritium. Ayan, ito silang tatlo are isotopes of hydrogen wherein they are all the same element, the same sila na hydrogen, the same sila ng atomic number which is 1, pero different yung mga mass numbers nila. So pag protium, ito talaga yung hydrogen natin kasi 1, 1. And then meron tayong hydrogen na 2 yung mass number. We call it deuterium or heavy hydrogen. Ito yung yung sa dagat natin. Merong water, 'di ba? Water H2O, that's protium actually. But yung sa deep part of the sea, meron kang makikita doon na D2O instead of H2O. That means instead of hydrogen na protium, heavy hydrogen siya, so D, deuterium, D2O. So if you want to ask me kung naiinom ba ang heavy hydrogen, yes, but in a small amount only. Ang hindi natin pwedeng inumin na hydrogen as component of water is yung tritium, because tritium is a radioactive hydrogen, meaning nag-e-emit yan siya ng radiation. So ayan, magkaiba yung mass numbers nila, which means ang nag-iba dyan is yung number of neutrons. Kasi si protium, when you subtract that 1 minus 1, 0. Meron siyang 0 na neutron. Si deuterium naman, 2 minus 1, meron siyang isang neutron. And si tritium, 3 minus 1, 2. Meron siyang dalawang neutron. So, yung mass number, kaya nagbago ang mass number na yan, it's because of the changes in the number of neutrons. And then, you have isotones. Sa isotones naman, yung similarities nila, pareho sila ng number ng neutrons. And yung difference nila is number of protons, which means class, ibang element yan. Again, pag nag-iba ang number ng protons, it means ibang element na yun siya. Kaya lang, pareho sila ng number ng neutrons. Ang tawag natin dyan, isotones. So, let's have an example. Isotones. Magkapareho sila ng neutrons, like this one. Si tritium, ganito. Tritium ito ha. And then, si helium, this is another element. We have 4, 2. Kung titingnan natin, ang neutrons and protons nila, ang neutrons nito, 3 minus 1, it's 2. And then, yung protons niya, since this is 1, so automatically this is 1. Now, for helium, the neutrons, 4 minus 2, that's 2. And then, since the atomic number is 2, so the protons here is 2. So, kung nakita nyo, the same ang neutrons nila, pero magkaiba yung proton. And automatically, magkaiba sila na element. We call them isotones. And then, we have the isobars. Now, sa isobars, magkapareho sila ng mass number, pero kagaya ng isotones, magkaiba sila ng element. So, magkapareho sila ng mass number. So, most likely, parehas lang yung isobars and isotones, no? Pero, mas specific kasi si isotones sa neutrons. And then, you have sa isobars, the mass number actually. Magkapareho sila. So, we call it isobars. And then, the last one, we have the isomers. Ito naman yung magkapareha sila ng molecule, kaya lang, nag-differ sila sa structure. Kaya, example niyan yung glucose and ang fructose. So, parehas kasi silang C6H12O6. Ito din, C6H12O6. Meaning, magkaparehas sila ng molecule. Pero when we draw their structure, magkaiba na. So, I hope you will have time to look for the structure of glucose. So, makikita nyo na magkaiba yan sila. Ang ending yan ay CHO. Pero ito, ang ending nito ay C double bond O. And then, meron siyang C, what do you call that? Double bond O R. Wala pa rin itong double bond dito. So, ito yung ending ng kanilang structure. I hope you will take time to research the structure of glucose and fructose. You will see there na similar yung chemical formula nila, pero different pag sinulat na ang totoong structure. We call them isomers. Next, let's move on sa allotropism. Ito naman, iba ito sa isotopes ha. When you say allotropism, ito naman yung property ng ating substance to exist in 2 or more conditions na magkaiba yung physical or chemical relation. Ang tawag natin sa substance na yan ay allotropes. So, ano ang example ng mga allotropes natin? Example, we have charcoal and diamond. Itong dalawa na to, they are called allotropes of carbon. Hindi kagaya ng isotopes na ang titingnan mo ay yung number of protons and number of neutrons. Ito, ang titingnan natin ang physical and chemical properties. Si charcoal class, you all know that this is made up of carbon. You know the appearance of charcoal, right? It's black. Madali siyang, I mean, 'di ba pag gusto mo siyang cut into smaller pieces, mas madali mo lang siyang i-cut. Pero again, it's made up of carbon. And then you have another substance here, diamond, which is also made up of carbon. Pero kung titingnan nyo yung itsura ng charcoal and diamond, magkaiba sila, as in total opposite. But magkapareho sila na ang component ay carbon. So ang tawag dyan, allotropes. Different yung properties nila. Ito, madali mong masira, madali mong makat into smaller one, but ito masyadong matigas, di ba? When you want to cut diamond, you have to use another diamond. Ganun siya katigas. Magkaiba sila ng properties. Again, we call it allotropes. Okay, so a while ago, we mentioned the term orbitals. So when you say orbitals, it is where we can find our electrons. Again, it is where we can find our electrons. It's a space, it's a region in space where you can probably see your electrons. That's orbitals. It's according to Schrödinger. Now let's move on to the study of our periodic table. Ayan. Before that, let's have a brief history. The first periodic table was made by Antoine Laurent Lavoisier. So he was the first one who made the first true periodic table. And then, later on, Johann Dobereiner grouped together the elements into three. He called it the law of triads. So for example, lithium, sodium, and potassium are grouped together into one because they have similar characteristics. So, sino ang nag-group niyan sa kanila by threes? It was Johann Dobereiner. And then, you have John Newlands. So, John yung pangalan niya ha. John Newlands. J-O-H-N. Ayan. Sa kanya naman, he grouped the elements into 8. 8 elements yung isang group according pa rin sa similarity ng kanilang characteristics. So, ang tawag niyan, law of octaves. And then, you all know Mendeleev, right? Dmitry Mendeleev. And then, together with Lothar Meyer, let me write his name. Okay, his name is Lothar Meyer. So, gumawa naman sila ng periodic table, pero yung arrangement ng mga elements ay according to their atomic weights. So, according to the two, the physical and chemical properties of the elements are periodic functions of their atomic weight. So, ano nila, ipasunod nila ang mga atomic weights sa mga elements. They arranged it. So, ayun, meron na tayong periodic table. But, it was Henry Moseley who arranged the elements in the periodic table according to their atomic numbers. So, magkaiba sila ha. Si Meyer and Mendeleev arranged the elements according to the atomic weights, while Henry Moseley arranged the elements based on their atomic numbers. So, huwag kayong ma-confuse kasi si atomic numbers again represents the number of protons, while atomic weight represents the number of protons plus the number of neutrons. So sa periodic table class, meron tayong tinatawag na period which is the horizontal row of our periodic table. So ano yung ini-indicate ng period natin? It indicates the highest energy shell that the electrons of an atom occupy. Okay, let me go back. When you say period, let me draw a periodic table sa screen since we don't have a periodic table here. So, diba, this is how you draw a periodic table. Ayan. You are all required to memorize the arrangement of the elements. So you have hydrogen, and then you have lithium, sodium, potassium, rubidium, cesium, and then francium. Ito lang yung sulat ko ha, for your reference. Bukas pa tayo matatapos ng susulat ko lahat. We have beryllium, magnesium, calcium, strontium, barium, and radium. Ayan, kung bibilangin natin, horizontal, pahiga ha, pahiga. So, ito yan. May helium ka dito sa kabila. Ito yung period 1 class. So, papunta doon. Hydrogen and helium both belong to period 1. And then you have period 2, 3, 4, 5, 6, 7. Ayan. So if you're asked, how many periods do we have in the periodic table? It's 7. And it represents the number of orbitals or energy shell na ino-occupy ng ating mga electrons. Which means, kung si hydrogen ay na-belong sa period 1, it means meron siyang nucleus and meron siyang isang orbital or energy shell. Diyan mo makikita ang electron ni hydrogen. So, di ba, si hydrogen, ganito. 1 yung atomic number niya, 1 din yung mass number. Which means, meron siyang isang proton, wala siyang neutron, and since wala itong charge, meron din siyang isang electron. So, nandito sa gitna, sa nucleus, yung proton niya na isa, and meron siyang energy shell na isa, dyan mo makikita si electron. And then, di ba si lithium? Si lithium nasa period 2. This means na aside from the nucleus, meron siyang dalawang energy shell or orbital. Yan yung nire-represent ng period natin. So, si lithium naman ngayon ay yung atomic number niya ay 3 and then yung mass number niya ay 7. Which means, meron siyang, this is 3, so meron siyang tatlong proton, meron siyang 7 minus 3, meron siyang 4 na neutrons, and then meron siyang electron na 3 din. Kasi walang charge. So, parehas sila ni proton. So, meron kang 4 protons sa gitna. And then, yung tatlong neutrons, makikita mo sa energy shell. Please take note na sa unang energy shell, ang pwedeng ma-accommodate niyan ay isa lang. I mean, dalawa lang. So, meron kang dalawang electrons there. And then, automatic, since tatlo ito, yung last na electron ay makikita mo sa outermost shell. Ayan. Yan yung sa period. The same thing with sodium class. Sodium belongs to period number 3, which means, aside from the nucleus at the center, meron siyang tatlong energy shell. Therefore, ayan, let's look at sodium. Sodium is 11, 23, which means meron siyang 11 na protons. And then, 23 minus 11, 12 neutrons. And then, since wala itong charge, meron din siyang 11 electrons. Excuse me. Okay, let us continue. Again, si sodium merong 11 electrons. Which means, ayan, meron kang 11 protons sa gitna, meron ka ding 12 neutrons. Now, ganito. Again, I mentioned a while ago, on the first energy shell, dalawa lang yung pwedeng ma-accommodate. And then, on the succeeding energy shell, succeeding ha, second up to the seventh period or the seventh energy shell, pwede na siyang maka-accommodate ng 8 electrons. That's what we call the octet rule. Na dapat 8 yung sa last na energy shell niya. So, meron kang dalawa and then lagay natin 8. 1, 2, 3, 4, 5, 6, 7, 8. So, these are all negative since these are electrons. So, 8 plus 2, that's 10. Meron kang isang natitira. So, meron kang isang electron sa outermost shell ng sodium. That's how you arrange their electrons. So again, to summarize, when you say period, it represents the highest energy shell that the electrons of an atom occupy. So kung sa potassium naman, sa case ng potassium, meron siyang 4 na energy shell since ang potassium ay nabilong sa 4th period. Yan. Next, let's have the family, or we call it group. But we have two types of family or group in the periodic table. We have family A and family B. Si family A, we call them the representative elements. So they occupy the S block and the P block, which means ganito. You have the periodic table like this again. Ayan. This one is the S block. This is the P block. Ito yung family A natin. So, sa S block, ang nabelong dyan is si group 1A and si group 2A. Malalaman mo naman na family A siya kasi yung pangalan ng group niya ay merong A, group 1A and then group 2A, excuse me. And then, ito naman si P block. So you have here boron, carbon, nitrogen, oxygen, fluorine, and then we have helium, and then argon sa baba. Ang ino-occupy naman ng P block is yung group 3A, 4A, 5A, 6A, 7A, and 8A. So all in all, ito yung tinatawag nating family A or representative elements. Group or family. So pag family class, ito yung vertical column ng ating periodic table. Si period horizontal. Ganyan. And then si family or group, pababa, we call it vertical column. And then yung family B natin, they are called the transition elements. Ano ang ino-occupy nila? They occupy the D block and the F block of the periodic table. So, ito yung D block. And, di ba sa periodic table, merong rows sa ilalim. At yun yung F block natin. So, si D block, ito yung tinatawag natin ng nasa gitna from 3B. Kasunod yan siya, nandito sa last yung 1, nandito sa last yung 1B at saka 2B. Ayan, kasunod hanggang 8B. Ito yung mga transition metals natin, yung nasa gitna, and yung sa baba na rows, we call them rare earth metals. Yan, that's the F block of the periodic table. Now, my question is, ano ba yung nire-represent ng family or yung group? Kasi, di ba, si period ang nire-represent ay ang highest energy shell na na-occupy ng electron. So, please take note when you say family or group, ang nire-represent niyan ay ang number of valence electron. Anong ibig sabihin ng valence electron? Ito yung electron found in the outermost shell. Again, pag sinabi mong valence electron, it's the electron found in the outermost shell. So let me give you an example. I would like to draw a periodic table again. Ayan. Then you have here 1A, 2A. Meron kang transition metal sa gitna. Then you have boron, carbon, nitrogen, oxygen, fluorine. And then you have helium and then argon. Ito ay tinatawag na 3A, 4A, 5A, 6A, 7A, and 8A. Let us concentrate to the sa representative elements kasi sila yung mga commonly ginagamit natin. And marami sila. So you have hydrogen, lithium, sodium. Then you have beryllium, magnesium. Sulat na ba natin? Halina, kay, ruby, cesium, francium. Then we have bemagka, sir, bara. Yung common na lang yung susulat ko, no? So after boron, you have aluminum. Then you have phosphorus here. You have, you have silicon here. And then, parang nabaliktad ko ata. Wait. Okay, let me draw that again now. I want a larger space for the periodic table at the same time for the examples. Okay, so let me draw that again. I have a periodic table like this. Ayan. So we are in the family, right? We are in the discussion about group or families in the periodic table. Again, let me have a review of that. When you say group or family, it's the vertical columns in the periodic table. So you have family A or group 1A here. And then you have 2A. Let's discuss first the representative elements. And then you have 3A, 4A, 5A, 6A, and then 7A. And then here we have the 8A. Representative elements. So you have Halina, Kai, Ruby, Cesium, and then Francium. I'll just write the common elements. And then we have here de, mag, ka, sir, ba, ra. And then you have here boron, carbon, nitrogen, oxygen, fluorine, and then we have helium, and then we have argon. Okay, so what does the group or family represent? I discussed a while ago that when you say group or family, it represents the number of valence electrons in an atom. And when you say valence electron, it's the electron or electrons found in the outermost shell of your element. So let's take, for example, hydrogen. Hydrogen belongs in group 1A. And then we learned also that it belongs to period 1. which means you have a nucleus and you have one energy shell. Now, looking back on the atomic number and atomic mass of hydrogen, we have 1 and 1, which means it has one proton, it has no neutron, and since this has no charge, it means pantay lang yung protons and electrons. So, meron ka ding isang electron. And for the case of hydrogen, since it has only one energy shell, automatic, you will be writing electrons in here. So this is the valence electron of your hydrogen. Kaya si hydrogen class andi dito sa group 1A. Kasi isa lang yung electron niya, isa lang yung shell niya, this becomes automatically the valence electron. But let's take, for example, lithium. Let's see bakit nandito siya sa group 1A natin. So, si lithium class, yung atomic number niyan ay 3. And then, yung atomic mass niya or mass number ay 7. So, si lithium class, nasa period 2. Ito yung period 2, di ba? So, ang meaning niyan, meron siyang nucleus, and then meron siyang energy, dalawang energy shell. Now, let's look at the subatomic particles of our lithium. This is 3. Therefore, si lithium ay may tatlong protons. 7 minus 3, meron siyang 4 neutrons. And wala siyang charge, so automatically you have here 3 electrons. Now, when we distribute it, always remember that the first shell can only accommodate 2 electrons. So you have 1, and then you have 2. And then, 3 minus 2, merong natirang isa. So you will be writing the last one on the outermost shell. Ito na yon, outermost shell niya, pinaka-last na shell ni lithium. So, ilang electron ang meron sa outermost shell ni lithium? Ito yon, isa. That is the reason why si lithium ay nabilong sa group 1A. Again, pag nabilong sa group 1A, it represents meron siyang 1 valence electron. Meron siyang 1 electron sa outermost shell niya. The same thing actually with your sodium. So, si sodium class, nasa third period siya, which means meron siyang tatlong, sorry, let me erase this one. Ayan. Ulit. Ayan, meron na siyang isa, right? And then, ikalawa, and then, tatlo. Now, si sodium class, yung, sorry na, hindi siya, sorry, mahirap talaga mag-draw dito. But anyway, we have atomic number for sodium is 11, and then its mass number is 23. So, the subatomic particles for sodium are, we have 11 protons, and then 23 minus 11, so 12 neutrons, and wala tong charge, kaya 11 electrons din. Now, let's distribute. Let's look at the valence electron of sodium. Again, on the first shell, it can only accommodate 2. So we have 1, and then 2. And then on the succeeding shells, from the second up to the last shell, pwede na siyang mag-accommodate ng 8 electrons. So let's draw. We have 1, 2, 3, 4, 5, 6, 7, and then 8. Ayan, meron siyang 8 electrons sa second na shell. So, ilan ang natira? 8 plus 2 dito sa first, so we have 10. And this is 11. Therefore, on the outermost shell of sodium, you only have 1 electron. Ito na ngayon ang tinatawag mong valence electron. That is the reason why sodium belongs sa group 1A kasi meron siyang isang valence electron. Let's have an example na hindi 1. Tingnan natin si oxygen. Okay, oxygen belongs sa group 6A. And nasa period 2 si oxygen. So, let's draw oxygen here. The atomic number of oxygen is 8. And then its mass number is 16. And then again, it belongs to period 2. Therefore, aside from the nucleus, you will have 2 energy shells. So you have 1, and then you have 2. Ayan. So let's look at the subatomic particles of our oxygen. You have 8 here, which means you have 8 protons. 16 minus 8, we also have 8 neutrons. And automatic, since this is a neutral atom, so equal C protons and electrons. So you have 8 electrons. So i-distribute natin ngayon C electrons. Again, ang ma-accommodate ng ating first energy shell ay dalawa. So you have 1 and then 2. And then we will distribute the remaining electrons in the outermost shell of our oxygen. So ilan ba yung natira? 8 minus 2, so we have 6. So we have 1, 2, 3, 4, 5, and then 6. So you have 1, 2, 3, 4, 5, 6 in the outermost shell of oxygen. This will be now its valence electron. So titingnan natin, si oxygen ay nabilong sa group 6A. So tama yung placement ni oxygen. So again ha, pag tinanong kayo, what does the group or family in the periodic table represents? It represents the number of valence electron. When you say valence electron, it's the electron in the outermost shell. Okay. So, na-mention ko kanina si octet rule. Si octet rule class, ang sinasabi nito, for an atom, sulat ko na lang, for an atom to be stable, it needs to complete 8 electrons in its outermost shell. So kung titingnan nyo class, from hydrogen, though hydrogen has only 1 energy shell, which means its requirement is only 2 electrons. 2 electrons lang ha kay hydrogen kasi isa lang naman yung kanyang energy shell. And then ang na-accommodate ng first energy shell ay dalawa. So itong hydrogen class, hindi siya stable kasi kulang siya ng isa. Kaya si hydrogen nagbabond with other elements for it to become stable. The same thing with lithium. Though si lithium, na-complete niya yung first energy shell, pero yung second energy shell, hindi na siya sumunod sa octet rule. Meron lang siyang isang electron. Kaya, isa lang yan siya, 'di ba? So kulang siya ng 7 before matawag natin siyang stable. This is the reason class bakit si lithium ang charge niya ay positive 1. Ito din positive 1. Kasi ang gagawin nila, ibibigay na lang nila itong isa. I mean, like lithium, pag nag-enter siya sa chemical reaction, ang tendency ng lithium ay ibibigay niya na lang yung isang electron sa ibang atom kasi yung kasunod na shell, kompleto niya naman. Ang tendency, meron siyang 3 proton sa gitna, pero pag binigay niya to, makukulangan siya ngayon ng isang electron, which makes it mas marami ang proton niya ng isa, kaya positive 1 yung charge niya. The same thing with sodium. The first 2 energy shells follow the octet rule. Kompleto niya. Yung first shell, meron siyang 2, and then sa second shell, meron siyang 8. But in the outermost shell class, isa lang. Kaya kulang siya ng 7. But it will be difficult for sodium to look for 7 for it to become stable. Thus, sodium will just let go of this electron. Ibibigay niya na lang ito sa ibang atoms. And then, pag nabigay niya yan, yung kasunod na shell class ay 8, kaya magiging stable siya. Therefore, since mas marami na ngayon si proton ng isa, proton 11, and then magiging 10 na lang, kaya positive 1 ang charge ni sodium. Ito namang si oxygen class. Ganito ha, tuturuan ko kayo, since you are all pharmacy students, you really need to memorize the arrangement of the periodic table. I-memorize nyo pababa. Mas madali siyang i-memorize kagaya ng sinabi ko kanina, halina, Kyrobi, cesium, francium, that's group 1A, and then Magka, Cerbara, that's group 2A, and so on. So, ganyan nyo siya i-memorize pababa para mas madali. And then, what's the advantage of memorizing the arrangement of the elements in the periodic table? You will know anong period sila na belong. You will know anong group sila na belong. Pag alam nyo yan, mas madali sa inyo ma-identify ang charges nila. So, ito yung mahirap kapag sa laboratory, nag-lesson na kayo no, ng types of chemical reaction. Kasi kayo yung ipasusulat ng chemical formula, kayo din yung magpe-predict ng, sa chemical reaction, kayo din yung gagawa, kayo magpe-predict ng products, and then kasama dyan yung mga charges nila. So para hindi kayo mahirapan, class, ang gagawin ninyo ngayon ay i-memorize niyo ang periodic table and always remember na lahat na nabilong sa group 1A ay positive 1. Silang lahat from hydrogen to francium ay positive 1. And then sa group 2A, automatic silang lahat ay positive 2. So from beryllium to radium, positive 2 talaga yan. And then, you have here group 3A boron, and may aluminum yan siya sa baba. So, silang lahat naman ay positive 3. Now, let's not touch carbon yet because carbon is the reason why we have the so-called organic chemistry. This subject is inorganic chemistry. So, hindi muna natin i-dig deeper itong carbon kasi iba yung mga reactions ni carbon, iba din yung properties niya. But anyway, si carbon and ang mga elements pababa ay either positive 4 and negative 4. So, kaya yan sabi ko, iba yung rules ni carbon. And then, pagdating mo kay nitrogen class, you have silicon here, and then you have phosphorus, pababa, ito silang lahat ay negative 3. And then oxygen, and then sulfur pababa, we have negative 2. And then you have halogens, we call this 7A as halogens. They are all negative 1. So lahat from fluorine, chlorine, bromine, iodine, and then astatine. Sorry, this is 80. Ayan, negative 1 sila. Ito namang group 8A, wala itong mga charge. Kasi si group 8A class, ang tawag natin sa kanila, noble gases. Noble sila because single sila forever. They don't react with other elements to form compounds. Kasi They are stable. Sana all stable. Bakit sila stable? Kasi they have completed the octet rule. Sa outermost shell nila, meron silang 8 electrons. So stable na sila. They don't need other atoms to help them to become stable. So except helium, because helium is na-belong siya sa group sa period 1, which means isa lang yung energy shell niya pero nakompleto niya din. Meron siyang 2 electron sa isang shell niya. So, yun lang naman yung requirement sa first energy shell, 2 electrons. So, nakompleto niya yan. The rest, argon, neon, krypton, radon, xenon, nakompleto nila yung outermost shell nila. They have 8 valence electron. So, again, wala silang charge. Now, to make your life easier, lahat ng elements na nasa gitna, di ba, remember, we call them transition metals. So, like the zinc. So, you can find zinc here. Ayan, silang lahat ng nasa gitna ay tinatawag nating transition metals. Lahat sila ay positive 2. Ayan, let us make our life easier. Hindi na kailangan you get crazy memorizing everything, no? So, hindi let's simplify everything. Meron lang itong mga exceptions sa gitna. Meron kasing mga elements na tigdadalawa yung charges nila or yung oxidation state nila. Like si copper can be positive 1 or positive 2. Yes, and then you also have, I'm thinking. And then you have also mercury, which can be positive 1 or positive 2 also. And then you have silver, siya yung exception kasi hindi siya positive 2, positive 1. Isa lang yung charge niya pero positive 1. And then si gold ay pwedeng positive 1 or positive 3. And then meron ka ditong lead. Nandito si lead, pero si lead can either be positive 2 or positive 4. Sorry, and then you have SN. SN is tin, so it can be positive 2 and positive 4 also. What else? Iron. So you have iron can be positive 2 or positive 3. The same thing with manganese. It can be positive 2 or positive 3. And cobalt also. So si cobalt, positive 2 or positive 3 din siya. Ayan, sorry, wait. So ayan. What else? Basta do not forget when you say group or family, it represents the valence electron. And kung ano ang group nila sa periodic table, yun din yung charges nila. Yan. Let me delete the writings screen. Okay. Now moving on. Ayan. So, this is not actually the current periodic table. Kasi yung bagong periodic table, may mga names na yan dito sa baba. Like livermorium, like that. Mga organism, meron na yan siya. So, di mo add to gira nga, wala mo ibala ha. So, sa inorganic chemistry, I really need you to have your own calculator at the same time, your own periodic table. So, para hindi kayo mahirapan, please start memorizing the arrangement of the elements in the periodic table ngayon. So, sabi ko, di ba, pababa niyo siya, i-memorize. Kasi mas madali yon. Like, halina, chirurgy, cesium, francium. That's mnemonics. We call that mnemonics, wherein we make abbreviations or meron tayong mga ginagawang mga paraan to memorize things easier. And then magka-serbara. Ayan. Pero, ang requirement ko sa inyo, i-memorize niyo itong periodic table, except itong rare earth metals. Itong lanthanide and actinide series. We don't really memorize them. The reason why we call them rare earth metals kasi minsan lang natin sila nakikita, no? Sa nature, sa earth. So, we don't really deal with them. Ang mostly dinideal natin is itong representative elements and the transition metals in the center. Ayan. Okay, so let's move on to another topic about periodic table. Actually, this is the last. We will be discussing the periodic trends. Meron kasing, ang ating mga elements kasi sa periodic table, they are arranged according to their characteristics or properties. So these are some of their properties. We have ionization energy, electronegativity. We also have electron affinity here, atomic radius, metallic character, non-metallic character. Ayan. That's the last one, non-metallic character. Actually, the arrows point kung saan mas mataas yung character, property niya. Let's discuss them one by one. So that's the periodic trends. Let's start with the atomic radius or atomic size. When you say atomic radius, it's half the distance between two nuclei. So if you have an atom here and then another atom, okay, the distance, half the distance between this one nucleus to another nucleus, half of that is called the atomic radius. But mas gagamitin ko yung atomic size kasi mas naiintindihan, mas madali siyang maintindihan when it comes to discussing the periodic trends. So ito yung periodic trend natin. From left to right of the periodic table, it decreases. And from top to bottom, nag-i-increase yung atomic size. So, para mas maintindihan, ganito siya, class. Kanina pa ako nag-draw ng periodic table. Okay, nahiwi na ako periodic table. But anyway, from left to right, this is the left side of the periodic table. From left to right, so this is left again, and then this is right. You have hydrogen here, and then helium. Yung atomic size daw, gaano ba kalaki ang atom, nag-decrease. Meaning, mas malaki si hydrogen kaysa sa kay helium. And mas malaki si lithium kaysa sa kay argon. Ganon yun, yung trend nila. As you go from left to right, nagde-decrease si atomic size. But, as you go from top to bottom, that's top to bottom. So you have francium at the bottom, or we have beryllium here, and then radium at the bottom. Take note of the trend. From top to bottom, nag-i-increase ang atomic size natin. So it can be explained because of the energy shell. Remember class, pag nasa period 1 siya, meron lang siyang energy, isang energy shell. Pag nasa period 2, dalawa, kaya lumalaki yung atom. Pag period 3 like sodium, syempre meron na siyang tatlo. Ayan, mas malaki na siya. How much more kung nasa period 7 siya na meron siyang 1, 2, 3, 4, 5, 6, mag-overlap na 7. Ayan. So, meaning, mas malaki talaga yung nasa bottom. Meaning, the largest atom that we have is the atom of francium. Kasi, nasa bottom siya, at the same time, nasa left side pa siya. Lahat ng elements na nandoon sa right ay maliliit na ng mga atoms. So, yun yung first na periodic trend. So, if you are asked, sino ang mas malaki? Si lithium ba o si beryllium? Ayan, makita niyo yung trend from left to right, nagde-decrease. And nasa left si lithium, nasa right si beryllium. Ito si lithium, ayan si beryllium. Meaning, mas malaki talaga si lithium. But if you compare, sino ang mas malaki compared kay lithium at saka kay sodium? So, si sodium ay nasa baba, kaya siya yung mas malaki. So, ganun ha. Kasi lumalabas to siya minsan sa board exam. Okay, so this one is an example, but this one represents only the S block and the P block. Inalis yung nasa gitna. As you can see, you have the boron carbon, di ba? Nasa, ano na yun siya, P block doon sa right side. Inalis nila kasi yung nasa gitna ng mga transition metals. But you will see here the differences between the sizes of our atoms. So what is the trend? The trend is from left to right, tingnan nyo, nagde-decrease yung sizes ng ating atom. But from top to bottom, ayan, ito ang bottom, actually it's until session only, nag-i-increase yung atomic size. Ayan, so ang mga questions nito sa board exam is, example, which is bigger, boron or carbon? Or which is larger, carbon or nitrogen? Or meron ding question sa board exam neto na arrange the following elements according to increasing atomic size or according to decreasing atomic size. So that is the very reason that I require you to memorize the periodic table, because how can you arrange them according to their atomic size if you don't know where to find them in the periodic table? You know the trend na from left to right, it decreases, from top to bottom, nag-i-increase. Pero kung hindi mo memorize ang arrangement ng elements sa periodic table, paano mo malalaman kung nasa bottom ba siya or nasa top? Or kung nasa right ba siya or nasa left? So, ayan. Start na kayo ng memorize ng periodic table natin. Okay, the next periodic trend is called electronegativity. Again, it's called electronegativity. Now, what is electronegativity? It is the ability of our atom to attract electrons. Again, this is a property or an ability of an atom to attract electrons. Meron tayong mga elements class or mga atoms na they have the ability na mag-attract ng atoms ng ibang element. Ina-attract nila yung atoms ng ibang kalapit na elements. So ito yung trend natin. From left to right, the electronegativity increases. Therefore, kabaliktaran siya ni atomic size. Kasi 'di ba si atomic size from left to right nagde-decrease. This is actually a total opposite of the atomic size. Because take note, from top to bottom, it decreases. So, as in, kabaliktaran talaga siya ni atomic size. So, ganito. In your periodic table, you can actually see there the electronegativity values of the elements. But I don't require you to memorize them. Well, mabuang na tani kung pati pa electronegativity i-memorize. So, again, you just need to memorize their arrangement. So, as you can see, okay, take note ha, dito sa noble gases, wala silang electronegativity because they don't attract electrons. They don't need electrons from other atoms since they completed the octet rule already. So, ito lang yung mga may electronegativity. As you can see, from left to right, it increases. So, ayan, 1.0, 1.5, 2, hanggang naging 4. But take note kung pababa ka, from top to bottom, again, from top to bottom, nagde-decrease. So, from 1.0, naging 0.7. Dito, from 1.0, naging 4.0. So, again, the trend is from left, okay, let me write, left to right, nag-i-increase. Wait. Okay, nag-i-increase. And then, from top to bottom, nagde-decrease naman ngayon. Nagde-decrease siya, 0.7:1. Now, additional thing that you need to know is, among the elements, the most electronegative atom is your fluorine. Again, the most electronegative atom or element is the fluorine. Take note, 4.0 yung electronegativity niya. Actually, the scientist named Linus Pauling called fluorine, ang tawag niya sa kay fluorine ay super halogen. Kasi si fluorine, kahit saan mo siya ilagay, magre-react talaga siya with other elements. Ganun siya ka-reactive. So, kasi mataas masyado yung electronegativity value niya. So nag-a-attract talaga siya ng electrons from other elements. Again, it's called super halogen. Yan. So ito yung trend again. From left to right, nag-i-increase. Pero binaliktad kasi siya. So from bottom to top, dun siya nag-i-increase. And then the third periodic trend is we have the ionization energy, or sometimes we call it ionization potential. So how do you define this? It's the ability of an element or an atom to remove an electron from a positively charged atom. Anong kaibahan nila sa electronegativity? Sa electronegativity, mag-a-attract lang siya ng electrons from other elements. Itong ionization energy, ito talaga yung magre-remove ng electrons from other atoms, especially yung mga positively charged atoms natin, or simply we call them cations. Yun yung pinagkaiba nila. Pero yung trend nila, yung periodic trend nila is pareho lang. From left to right, nag-i-increase yung ionization potential or energy, and from top to bottom, nagde-decrease din siya. So, ayan. From left to right, nag-i-increase. From bottom to top, nag-i-increase. But if you are asked what is the element with the highest ionization energy, it's or potential, it's helium. It's not fluorine. Fluorine has the highest electronegativity, but the one that has the highest ionization potential, it's the helium. So si helium yung may pinaka mataas na energy to remove an electron from a positively charged atom. I-remove niya talaga. Hindi siya nag-a-attract, pero magre-remove siya ng electron. And then the third one, is this the third one? Okay, the third one, we have, the fourth one, we have the electron affinity. Na ano naman yung pinagkaiba nito from the other two? It is the property of an electron of an atom to accept an electron. So baka malito kayo. When you say electronegativity, ang tandaan nyo ay attract. It's about electron kasi. So electronegativity is attract. Ionization energy is remove. I-remove niya talaga yung electron. But electron affinity is accept. So mag-a-accept siya ngayon ng electron from other elements. However, the trend is still the same. From left to right, increases. From top to bottom, decreases. So, ganun pa rin yung trend. So, yung naiba lang sa periodic trend natin ay yung atomic size. Yan. So, again, ito yung illustration nila. Si ionization energy, electron affinity, dagdag natin dito si electronegativity, parehas sila ng trend. And then you have the atomic radius, which is the total opposite. And take note of this, the non-metallic and the metallic character. Discuss lang natin. So when you say non-metal, you can find them here sa right corner, sa right part ng ating periodic table. Kaya yung arrow is papunta doon. As you go from left to right, nag-i-increase yung non-metallic character. And pataas yan, meaning from bottom to top, increasing yung non-metallic character niya. And then yung mga metals naman, ito yung mga gray na part. Ayan. Ang trend niya naman is nandito na naman siya sa right side. Kaya yung arrow niya papunta dito. Meaning yung element na pinaka-metallic is ito, nandito na part. Like francium, ayan. Kaya radium, magkatabi yan sila eh. So radium. Yan. So when you say non-metallic character, it's the ability to gain an electron. So, yung mga non-metals natin, sila talaga yung nag-gain ng electrons. And then, yung metallic character naman, this is the ability Kabaliktaran lang. To lose an electron. So mostly, ang naglo-lose or nagbibigay ng electron ay yung mga positively charged natin, yung mga metals. And then yung mga non-metals natin, sila naman yung nagre-receive ng electrons. So that's the periodic trend. Okay, now let's add melting point. Itong melting point, ito kasi yung energy required para ma-break ang bonds na yung solid mo ay mag-turn into the liquid phase. So, for example, yung ice na solid, pag na-subject yan siya sa high temperature, syempre magbe-break yung bonds and then the ice will turn back into liquid. Magiging water siya ulit. That's the melting point. So, si water, yung melting point niya, 0 degree Celsius. So, itong melting point na ito, wala siyang trend. So, hindi siya kagaya ng atomic size, electronegativity, affinity, and ionization energy na may sinusunod na pattern sa pag-arrange nila sa periodic table. Itong melting point, wala. So, as you can see, ayan, ito yung mga melting points ng ating mga elements. So, ang nakikita nyo dyan, carbon has the highest melting point. The rest, ayan, erratic na. So, again, wala talaga siyang sinusunod na trend sa periodic table. You just have to take note that metals generally possess a high melting point. So, basta metal, mataas yan yung melting point nila. Mataas na temperature ang required para tunawin mo yung mga solid na mga metals. But, most non-metals possess low melting point. Meron lang tayong exception, which is si carbon. Si carbon kasi ay non-metal pero siya yung may highest na boiling point at saka melting point. And then actually boron also. Boron is not a metal, it's a metalloid or a semi-metal pero mataas din yung melting point niya. Ayan. So, ayan. Thread. So, sa thread na naman ito. So, this will be thread, I think, thread number 5 na ba or thread number 4? Anyway, this will be the last thread. You have to answer this. Ayan. Which of these elements has the largest atomic radius? So, doon sa thread, you write number 1 and then you write the letter of your choice. Kung sino sa kanila yung may largest atomic radius. So, please follow the rules sa sa atomic size doon sa periodic trends. And then number 2, answeran nyo din ito, which of these elements has the lowest ionization energy? So, titingnan ko kung naintindihan nyo yung periodic trends sa ionization energy. Kasi, i-determine nyo sino sa kanila ang may lowest ionization energy. Sodium, phosphorus, chlorine, aluminum, and sulfur. So, please, kuha kayo ng periodic table nyo and hanapin nyo based on the rules sa periodic trends, sino sa kanila ang may lowest ionization energy. So that's all for the introduction to inorganic chemistry. For any questions, I'll be placing a discussion thread also sa week 2 lecture na folder for your questions. Kung meron kayong clarifications or meron kayong questions, so i-type nyo doon sa thread for questions and then i-answer ko yun one by one. Ha? So that will be all for the introduction to inorganic chemistry. Thank you.